Okay, so continuing with the series of analysis videos on elastic collisions, this is number 4. So we're going to deal with this experiment here. So each time I'm going to put the link in the, I put the link in the description. Over here we have, so I'm going to try to make this video as short as possible because the other videos are pretty long. So we have a small mass, and you can see this larger mass is almost 3 times as heavy. Now, the only problem is this is a very low quality video. It doesn't say the data out loud, or you can't hear them quite well, but it's all written on the board. But since it's pretty low quality, it's not, you can't really read it that well. Luckily, I have still good eyes, I can read it. So hopefully you can read it too. So there we go. This is the experiment. All right, so I don't know if you can see this, but over here we can see he has written down the mass of the first card, which is 0.244 kilograms. And then between parentheses, we can see the velocity, which is 0.47 meters per second. So you can hear him saying it, 0.47. All right, then in the middle we have the velocity of the card 1 bouncing back between in parentheses, and it says 0.19 meters per second. So yeah, it's speaking pretty unclearly, but I can read it. It says 0.19 meters per second, and over here we can see the mass of card 2, which is 0.635 kilograms, and then its velocity after collision, which is 0.26 meters per second. So that's all we need. That's the data. I hope you can read it. I can read it. So now I did all the calculations. So I'm just going to go through over this. I'm not going to spend time on the process of the calculations. Okay, so the prediction. So the prediction for part 1 after collision, so the reflection, is 0.209 meters per second. So we can round it off to 0.21 meters per second, and the actual result is 0.19 meters per second. So 0.02, a difference of 0.02, which is 9.9%. Now I got to say that in the when I compare it with the other analysis videos, there is a consistent, it's pretty significant that there is the difference between the prediction and the result for part 1 after reflection is always significantly bigger, right, than the other differences between results and predictions. So 9.9% difference, and for part 2 after collision, the big mass, the prediction is 0.261 meters per second, and the actual result is 0.26 meters per second. So it's perfect. It's near perfect. So it's spot on. It's a very precise prediction. Okay, so now the conservation of momentum. The total amount of momentum before collision is 0.1146 kilograms meters per second, and then the momentum of part 1 after collision, we treat it as a vector, so it becomes negative since goes in the opposite direction. So we get minus 0.0463, and then the momentum of part 2 after collision plus 0.1651. If we add those together, we get 0.1188. And so we can see the difference between this net result and the initial momentum is, so we get 0.1188 versus 0.1146, which is a difference of 3.6%. It's a rather small difference, I would say. It's not too terribly big. Whereas if we add them together, the difference would be a lot bigger. And now for the kinetic energy, the total amount of initial kinetic energy is 0.0269 joules. And then when we add the kinetic energy of both cards after collision, we get 0.0258 joules, and that is a difference of 4%. Again, not too terribly big of a difference. So again, it's always the first card after collision that has a bigger difference than all the other predictions. But I would say, yeah, the formula still is pretty reliable, I would say. Especially in momentum, the conservation of momentum, when we treat it as a vector, okay? So for the reflection, if we treat it as a negative momentum, then the result is that in the end, the total momentum is always very close to the initial momentum. It's always more closer than, whereas when we add them together and when we don't treat it as a negative momentum. So anyway, so this is it. I got more videos to come, more analysis videos, so stop recording.